Hi everyone, in this video I'm going to show you how to write a time lock smart contract in Solidity for the EVM or Ethereum ecosystem. So what is a time lock smart contract? Essentially, this contract allows you to um, postpone the execution of transaction. This is one of its main functionality. So what is this application? Why you should do that? There are a lot of situation in which you are not really sure about the source of transaction, and it might be malicious. So you need to buy some time to audit the situation and take the action. And there are also a lot of other applications in DeFi. And so in this video, I'm going to show you how to write this quickly, easily, and how we can test that on Remix. So let's do it.
Okay, now it's time for coding. First, let's make our smart contract. I would call this time lock contract. And so now we use pragmas. So I use Solidity 0.8 because I want to use also custom errors and want to take fully advantage of this version of Solidity. So here is my contract. I call this TL, which represents and stands for time lock. And now I'm gonna define a bunch of custom errors, and I do that for two reasons. First, I want to reduce gas consumption of my contract because I use this version of Solidity 0.8, and the other thing is it helps me to organize my code. So here are the custom errors. So later on I explain you what they do, but in brief, here is when we can't find the owner, when a transaction actually is inside of queue and we want to queue this again, then we raise this error. When for the execution time, when timestamp actually is not in range, and when we want to execute a transaction but it doesn't exist in queue, and this one is when timestamp actually doesn't pass, and here is the expiration error, and here is transaction failure. All right, now we have three events and help us to log on the blockchain. So one event is queue, the other it basically raises when we add a transaction into our queue, and the other one is execute, when we execute a transaction, and this is cancel when we cancel the transaction. And here are basically our constant. We need to have some minimum delay, maximum delay, and grace period. And any numbers here are in seconds. And here we have a local state which represent the owner, and here we have a mapping that represent the queue. So our queue is quite simplistic. We have transaction IDs, we hold them in byte 32, and then we have the status of that transaction. True means that's in queue, and false means this is executed and this is out of queue. All right, so now here we define our constructor. So in our constructor we need to basically identify and specify the owner of the contract, and to do so we also need to we need to also define only owner modifier to tell us who is the owner, and only the owner is able to deploy a contract. All right, now here we specify our constructor, and here we pass the address of sender or deployer as the owner, and here we hold the owner, and here we define a modifier that tells us who is owner, and if the address wasn't owner, then revert the whole thing and invoke this basically custom error. All right, so now we define get transaction ID function, which is a public function, and it returns basically a code for us without changing the state of the contract, the state of blockchain. So here we pass the target of the smart contracts, and then we pass value. We pass the function name, data, and timestamp, and we use ketcheck 256 in order to 32 byte transaction ID out of them. Here is our function queue, which actually adds transaction to the queue, right? So here we get again the address of contract, and we get value. Then we get the function name and the data for that function and timestamp. So this function is only owner, and only the owner can invoke that. We here specify this modifier on the owner, and it returns the transaction code and says, hey, this is now in queue. So what we do first we based on the information of target contract, value, function name, data, and timestamp, we make a unique code. We call this transaction ID, all right, with this function. And then we check it out whether it's actually already in the queue or not. If it's in the queue, it's already in the queue, so we don't need to add it again. And here we raise basically this custom error. And the next line, if everything is all right, then we check the timestamp. So if it was smaller than timestamp, block timestamp plus minimum delay, or it was bigger than block timestamp plus maximum delay, here is the place that you define the delays and how much you want to postpone the execution of a transaction. If you want to make it a month, so you need to calculate that based on seconds and put this stuff here. So just for the sake of simplicity, I just put the small numbers here. But in real life, DeFi's, the numbers are actually way more higher. So here, if it was like that in this condition, so this is not in the range. So we don't do anything about it, and we raise error and we get out. And when everything was all right, then we pass this to our mapping, right? And we set the status to true. And then we emit this event queue to log that on blockchain. So that was our queue function. And the next important function is the execute function. So the queue function, we pass the same argument here, and this basically function is payable, so we need to add this payable here. So why we have this payable function here? Because we need to make sure this function actually is allowed to receive ether and send ether out of contract. So you got to basically add this modifier and also go over here and specify that. So first we calculate the transaction ID, right? And then we make sure this transaction ID actually exists inside of the queue. So if it doesn't exist, so it's not in queue, right? Then we revert the whole thing and raise no queued error, custom error over here. And after that, we make sure about the timestamp. So if the timestamp basically is, or the blockchain time, the current time of the block is less than received timestamp, then it's not passed, right? Again, it rises a custom error. If it's bigger than that, plus grace period, then you need to say, hey, this timestamp is expired. If everything was all right, we didn't trap in any of these problems, then we move to this statement here, and we said, all right, so this transaction now get executed or is in the process of execution. So we set the status to false, right? So we set the status to true when we want to put something inside of queue and it still is not executed, and we are in this delay time, postpone time, and then we execute that function, that transaction. When we try to execute that, then we change the status to false, okay? And here we try to find prepare the data over here. We want to get the function from data because we receive basically a stream of bytes, okay? So we have to find selector plus the function, and we find that, we decode this, we encode this ABI, use ABI for encoding data, and then when everything is all right, then we use target call. So we call the function and along with argument, potential argument data of the target or locked contract. And if that didn't work for us, then we need to say, hey, we have a transaction fail, it didn't work. And when it worked, then we emit this event, execute, and log the whole thing on blockchain so we can see that works properly. All right, and the last thing is the function cancel. So what does it do for us? Once basically we decide to cancel a transaction, we just need to pass the transaction. This is again external, and it only be invoked by the owner. It can be invoked by the owner. And if that transaction doesn't exist in queue, then it's meaningless to cancel that, and we just raise this custom error. Otherwise, we just set the state of that boolean to false, and we emit basically this event here, and we log the whole thing in the blockchain. So basically, that's our time lock contract. This is our minimalistic basically contract to show you the concept. And now we can go on Remix and run this and see the result.